Hello. In this video we're going to look at the idea of quadratic equations. And we're going to look at what they are, what some important features of them are on the graph, how to graph them, and how to find those important features as well as how to solve them. We will then use them in an application problem and see how that works as well. So I'm going to be using part 2 of the notes that are located on a Blackboard site for Chapter 7. So let's go ahead and go to those now. Okay, so here are the notes. I want to start off with what a quadratic equation looks like. And so here's just a real basic quadratic equation. And it's going to be of the form y equals ax squared plus bx plus c. And the a, the b, and the c here are just any real numbers. So a, b, and c are any real numbers. So they could be 5, negative 3, 0.2, negative 11 halves. They could even be 0. You could have a 0 here or a 0 there or whatever. All right, so that's the basic form of a quadratic equation. And those a, b's, and c's will come up later when we review how to deal with the quadratic formula. But let's take a look at what a graph of a basic quadratic equation looks like. And so I'm going to graph y equals x squared. Alrighty, and in order to do that, what I'm going to do is I'm just going to come up with some points, pick some x values, plug those in, and find the y values that go with them. I'm just going to pick real standard, easy x values of negative 2, negative 1, 0, 1, and 2. And my y values are going to be, when I stick in negative 2 squared is positive 4, because a negative times a negative is a positive. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. Then I'm going to go and I'm going to graph those on my xy plane. And so I've got x values of 1, negative 1, and 2, negative 2. And I've got some y values here. And so 0, 0 is here. 1, 1 is here. 2, 4 is up here. So notice it's not in a straight line anymore. It's got some curvature to it. Negative 1, 1 is here. And negative 2, 4 is here. And when we graph those, we get a shape that looks like this. And if you remember from your previous math courses, the name of this shape is a parabola. Now there are some important features on the parabola. One that you've probably talked about before, but we're not going to spend much time on in here, is notice if I was to draw a line right along the y-axis here, the graph is the same on either side. All right, we call that symmetry. If I was to take the right-hand side and delete it, and then mirror the left-hand side, I would get the right-hand side. So this line right here is called the axis of symmetry. Again, we're not going to use much with this in this course. The other important feature is this spot here, the low point, or if the parabola was shaped this direction, it would be the high point, and that is the vertex of the parabola. Okay? There's also, if my parabola wasn't going through the origin here, I could have some places where it hits the x-axis, called the X-Intercepts, and some places where it hits the y-axis. All right, so let's go to the characteristics of parabolas. The first characteristic is that we have that vertex. And it's actually fairly easy to find the vertex. What we would do is we would start by finding the x-coordinate of the vertex. And to find the x-coordinate, what I'm going to use is I'm going to use these values up here, and I'm going to say that the x-coordinate is found by taking the opposite of whatever your b is and dividing it by 2 times whatever your a is. And that's going to give you your x-coordinate. Now that's the only thing I'm going to give you a formula for, because once you have the x-coordinate, if you want the y-coordinate of your vertex, you would just plug that value in for x in your original equation, and you could solve for the y. The other two things that you could find are the Y-intercept. And in order to find the Y-intercept, remember everything on the x-axis on the y-axis has an x value of 0. So what we do is we let x equal 0 and solve for y. But notice when we do that up here, if we let x be 0, this term is gone, this term is gone, and the only thing you're left with is c. So if we solve for y, we're going to get c. So that tells us that our y-intercept is just the point 0, c. And that's going to be the only one. So notice there is only one. It's only going to hit the y-axis once. The other thing we could find on the parabola is our x-intercept. And for the x-intercept, remember anything on the x-axis has a y value of 0. So what we want to do is we want to solve 0 equals ax squared plus bx plus c. And you can solve that one of two ways that you remember from your previous math courses. You could either solve by factoring, and then setting your factors equal to 0, or you could use the quadratic equation, okay, or the quadratic formula, quadratic formula. Okay. Now, do you remember what the quadratic formula looks like? Well, let's just remind ourselves. If we have 0 equals ax squared plus bx plus c, the quadratic formula says we take the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Alrighty? So we'll be using that again. And when you graph the parabola, you could have a lot of different things that it would look like. It could look like this graph that we had up here, or maybe it is down lower, maybe it's up higher. Okay, notice this one has 2 x-intercepts, this one has 0 x-intercepts, this one has 1 x-intercept, but they all have a y-intercept. Alrighty, so for x-intercepts you could have 0, you could have 1, or you could have 2. You could also have a parabola that is going down like that. All right, so those are all the different kinds of things that could happen with the graph. So let's look now at an example of finding the vertex. And what we've got here is the equation y equals 2x squared plus x minus 3. And I want to find the vertex of that. So if I go back up above, we remember that the x-coordinate for the vertex is negative b over 2a. So in this case, I'm going to say my x-coordinate is my negative b. So my b in this case is a 1, an understood 1 there. So it'd be negative 1 over 2 times our a value, which is 2. So notice our x-coordinate is negative 1/4. Alrighty. Now we need to find our y-coordinate. And what I'm going to do to find that is I'm just going to plug this value in for x everywhere and solve for y. So I get 2 times negative 1/4 squared plus negative 1/4 minus 3. And it might be easier if I do that in decimals, because then we can use the calculator. So I'm going to turn that into negative 0.25. 2 times negative 0.25 squared plus negative 0.25 minus 3. And one of the really nice things about graphing calculators is that you can plug that whole thing in there, and the graphing calculator will do all your order of operations for you. So let me just go ahead and plug that all in here. And I'm going to type it in just as it's written there. So I'm going to say 2 times, I'm going to go ahead and put a times in there, 2 times parentheses negative 0.25, close parentheses, squared, plus negative 0.25 minus 3. And then hit enter, and I get my y value as negative 3.125. Negative 3.125. So that gives me my vertex is negative 0.25, negative 3.125. Okay, so there's my vertex for this equation. Now I want to use that same equation, and I want to find my x and my y-intercepts. So the y-intercept is easy. Remember from up above that the y-intercept is just going to be 0 for x, and once you make x equal to 0, then c is the only thing that's left, and that's going to be your y-intercept. So my y-intercept is going to be 0, and my c value for this equation is negative 3. That's my y-intercept. Now I want to find my x-intercept. And it could be 1 intercept, could be 2 intercepts, could be 0 intercepts. And what I'm going to do for that is I'm going to set this equal to 0. And I'm going to solve that. Now, if you remember how to factor, great. You can go ahead and try factoring on that one. And it does factor fairly nicely. But if you don't remember how to factor, let's just go ahead and see if we can remember how to use the quadratic formula. So here is our A. Our B, remember, is a understood 1. And here's our C. So we have x is going to be the opposite of b. So if b is 1, we're going to have negative 1. Plus or minus the square root of b squared, so 1 squared, minus 4 times a is 2, times c, which is negative 3, all over 2 times a, which is 2. Okay, so let's see if we can simplify that. So we get negative 1 plus or minus. Let's see, from here we get 4 times 2 is 8. 8 times negative 3 is negative 24. So we've got 1 minus a negative 24, which is the same as 1 plus 24, which is 25. So square root of 25 over 2 times 2, which is 4. Square root of 25 is 5. So we get negative 1 plus or minus 5 over 4. So negative 1 plus 5 would give us 4. 4 over 4 is 1. Negative 1 minus 5 would give us negative 6. Negative 6 over 4 is negative 1.5. So those are our two x-intercepts. And we could write those as points. We could write them as 1, 0 and negative 1.50. All right. Now, the last thing I want to do, now that we've got all those values, is I want to use all of those to graph that parabola. So let me put in a graph here. All right. And let's see, I have negative 3 down there, and I'm going to go out 2, 3, 4, 1, 2, 3, 4. Now, the first point that I had was I had a vertex of negative 1/4, negative, and a little over negative 3. So negative 1/4 be about here, a little over negative 1/3, be about down in here. Okay. Then my y-intercept was 0, negative 3, so that's going to be here. And my two x-intercepts are at 1 and at negative 1.5. And now I've got everything I need to draw a picture of my graph. Okay? So there is a quadratic equation, some of the features of it, and how we can use those features to provide a graph. Let's go now to a word problem using a quadratic model. So what I've got here is, in physics, when an object is dropped or thrown, the height h an object is above the ground after time t can be modeled by the following equation. H equals -1/2 gt squared plus v, we pronounce this v naught t, plus h naught, where g is the gravitational force, and that's -32 feet per second, v, and that should be v naught, sorry about that, v naught is the initial velocity, and h naught is the initial height. Okay? So, if we have the following problem, a baseball is thrown from the outfield upward at an initial speed of 32 feet per second. So here is our v naught. And at a height of 4 feet, so there is our h naught. The height of the ball above the ground at time t is given by what? Well, h is equal to -1/2 times g. We know g is 32. And I'm not going to put in all of the units here because they'll actually all play out correctly. T squared plus my v, my initial velocity here is 32, and my initial height is 4. So what that gives me is h equals -1/2 times 32 is -16 t squared plus 32t plus 4. All right, so that is my equation. Now, if you look down at the bottom, we've got some questions that we're going to answer. We want to graph the equation, find the values of t that make sense, find the maximum height, and find how many seconds before the ball hits the ground. So I'm going to start with the graph, and in order to do the graph, I'm going to find those 4 pieces of information we talked about on the last page. So I've got h equals -16t squared plus 32t plus 4, and I'm going to start by finding the vertex of this thing. So when I find the vertex, this time I have a t as my independent variable. So my t, or my x, the t's have taken the place of the x's. T is equal to -b, here's my b, so -32, over 2 times a, and my a is -16. So -32 over 2 times -16, that would be a -32 as well. So that comes out to be 1. Positive 1. If I plug a 1 back in up here, I get -16 times 1 squared plus 32 times 1 plus 4. That's going to be -16 plus 32. That's 16 plus 4 is 20. So my vertex is 120. Now the next thing I want to find is my Y-intercept, or in this case my H-intercept, since H has taken the place there. So H-intercept, remember what we're going to do for that is we're going to plug in a 0 for t, or for x, and these all knock out, both of those terms, so we get just a 4. So it would be 0, 4. And to find our t-intercept, I'm going to let h equal 0. So I'll get 0 equals -16t squared plus 32t plus 4. All right. And I don't want to try and factor that because I have a feeling it's not going to turn out nicely. So I'm going to use my quadratic formula. The opposite of b would be negative 32 plus or minus the square root of b squared, which would be 32 squared, minus 4 times a, which is negative 16, times c, which is 4, all over 2 times a, which is negative 16. All right, so let's take that a piece at a time and see what we get. If we plug into the calculator 32 squared minus 4 times negative 16 times 4, we get 1280. So we get t is equal to negative 32 plus or minus the square root of 1280 over negative 32. So now what I'm going to do is I'm going to do the plus or the minus. So I'm going to type this in. I'm going to put parentheses around the numerator. So I have negative 32 plus the square root of 1280. And I'm going to close the parentheses on the square root and then on the numerator. And then that whole thing is divided by a negative 32. Okay, and when I do that, notice I get kind of a mess. So what I'm going to do is I'm going to round that off, so I get t is about negative 0.12. All right, now, in order to, instead of retyping the whole thing, I'm going to hit second and enter, and what that does is that gives me my last entry, and then I can arrow up and arrow over and change that to a minus, or a subtraction. So I did negative 32 plus, and now negative 32 minus. And there I get, I'm going to round off again, 2.12 approximately. So here's my two values for my t-intercept. So now, if I graph that, alrighty, let's see here. I've got 3, 4, 1, 2, and up here I'm going to go 5, 10, 15, and 20. Okay? And this is 1, 3, 4. So here is my t's, and up here is my h's. Okay. So my intercept, or my vertex, was 120. So that's up here. My h-intercept is 0,4, so that's about right here. My t-intercepts are negative 0.12, so about there. And then 2.12, so about there. Okay, so kind of a crummy looking graph, but all right, you get the idea. It looks like a parabola. Okay, and here's the high point, and here's the t-intercepts, and here's the h-intercept. Now, notice when we look at that, okay, hopefully that cough thing worked. When we look at that, we can use that to answer some of these questions down at the bottom. So I graph the equation. Now I say, what values of t make sense in the context of the situation? Well, the values of t that make sense are the ones that have positive h values, right? So they're only positive up until a little over 2 seconds. So it makes sense to start at 0 time and go out to a little over 2 seconds. What's the maximum height of the ball? The maximum height is right up here, and the height value is 20, and the time that occurs is 1. And then how many seconds will it take for the ball to hit the ground? Well, when it hits the ground, the height is 0, and that occurs down here at that X-intercept. So notice we can use all of the values here that we found to answer these questions. So values of t that make sense in this case are t's between 0 and 2.12. The maximum height is 20 feet, and that occurs at 1 second. And how many seconds will it take for the ball to hit the ground? About 2.12 seconds. All right, so that is the ideas with quadratic equations.